Welcome, class. In this video, we will go over lesson 8.6, Solving Quadratic Equations by Factoring. We'll be going over the Practice A worksheet. Let's just do a quick review first on what it means when we say we're solving by factoring. If we have an equation like, let's see here, x squared minus 3x plus 2 equal to 0, and I ask you to solve it. When we're solving, we are finding the x-intercepts, also known as the solutions, also known as the zeros. And we're going to use a couple steps in solving. The first step we're going to review is we're going to use this method here where we multiply the first number and the last number. It's called splitting the middle. We're going to find the factors of the first term times the last term. Oh, let me turn off this function here. There we go. The factors of 1 times 2 is 2. So we need to find the factors of 2. Factors of 2. And they must sum to the middle term. And the middle term is of course, negative 3 right here. Whoops. Negative 3. Sum to negative 3. Let two numbers multiply to 2, but they sum to negative 3. If we have two negatives multiplying to each other, we can sum them to a negative 3. If we had negative 2 and negative 1. Negative 2 and negative 1. Now we're going to use what's called splitting the middle. So x squared minus 3x plus 2 equal to 0. Sorry, it's just Microsoft. And we're going to be splitting the middle, which means we're going to split the middle term here into minus 2 and minus 1. So this one will be x squared minus the 2x minus the 1x plus 2 equal to 0. And we can show you here. So this is what we split the middle term to. And now this is a review, of course. We've done factoring in other lessons, but it's just a quick review. Once we get to 4 terms as part of splitting the middle, we're kind of switching to another method called factor by grouping. We have 4 terms. You just factor out the GCF in the first 2 terms and the GCF out of the last 2 terms. For x squared minus 2x, what can we factor out? We can factor out an x. If we factor out the x, we're going to get x minus 2. And if we're not sure if we factored properly, just go ahead and distribute back in, and you'll get the original x squared minus 2x. Now we look at the last 2 terms. Whenever the term is a negative, whenever this third term here is a negative, be sure to factor out the negative. In this case, all we can factor out is a negative 1. And we get x minus 2, still equal to 0. Now we're going to employ the final method of factor by grouping. We just factor out what's in common, which of course is the x minus 2 and the x minus 2. So we'll factor out the x minus 2, and what is left is the x minus 1 right here. We'll put these together to x minus 1. And we set it, of course, equal to 0. And now to solve this, we use what's called the zero product property. We just set each term equal to 0. X minus 2 equal to 0. Or x minus 1 equal to 0. And we solve now. But we just add 2 to both sides. In the first one, we get x equals 2. Or we get x equal to 1. Those are our 2 answers, 2 and 1. Keep in mind, this is a quadratic equation. The original x squared minus 3x plus 2 is a parabola, and we just found where it crossed the x-axis. And we can actually verify it by graphing it on a calculator. I'm just going to go ahead and just verify it right here. Let's see here. Here we go. X squared minus, was it a 2x? I'm trying to remember what it was. I think it was minus 3x plus 2. I believe that's what the the values were. Let me zoom in a little bit. And see the two x-intercepts right here? Whoops. We have an x-intercept here at 1 and another x-intercept at 2. X equals 1 and x equals 2. Now let's look at the homework. Number 1, complete. If a times b equals 0, then we're using the zero product property. We're just setting each part equal to 0. We're going to set a equals 0, a equal to 0, and then b equal to 0. What a represents really is like some parentheses that's factored, and what b is representing is another parentheses. We just set those equal to 0 as part of the zero product property. In this case, we're just going to write a equals 0 or b equals 0. And just notice for math, we use the word or. We don't say and. You'll hear that mistake made a lot. Students will say x equals 2 and x equals 3. We don't say and because that's impossible. X cannot equal two different numbers at the same time. That's just not possible. So we say or. Now, number 2, we already have something in factored form, and we're using the zero product property. X minus 7 equal to 0. This is like the a equal to 0. And x plus 2 equals 0. And that would be the b part equal to 0. We just solve. We add 7 to this side. Here we will subtract 2. And that's it. Those are our two solutions. Number 3, x minus 5 times x minus 1 equals 0. It's already factored for us. Now we set x minus 5 equal to 0. We solve for x. We get x equals 5. We add 5 to both sides. Over here, we're going to add 1 to both sides, and x equals 1. There's the other solution. For number 4, x plus 2 times x plus 6 equals 0. We say x plus 2 equals 0, or x plus 6 is equal to 0. We solve for x by subtracting 2 to both sides, and we get x is equal to minus 2 as one solution. Or we can subtract 6 from both sides, and we get x equals negative 6. And those are our two solutions, x equals negative 2 or x equals negative 6. Number 5, 3x minus 4 equal to 0, or x minus 3 equal to 0. We're going to first add 4 to both sides, and we'll get 3x is equal to 4. And we just divide both sides by 3. So x equals 4/3. Or x equals, on here we'll add 3 to both sides, and we get x equal to 3. Number 6, this is factor each quadratic expression, then use the zero product property to solve the equation. We have two terms here, x squared minus 5x equal to 0, and they gave us a hint. They factored out the x. X times what would give us the original x squared minus 5x? Well, if we factor an x out, there has to be an x here, because x times x would give us x squared. And then x times what would give us the minus 5x, and that would be minus 5. Now we use the zero product property. We set this part equal to 0 right here, and we get x is already equal to 0. Or we do x minus 5 is equal to 0. And of course, we add 5, and we get x is equal to 5. So we have two solutions, 0 or 5. Number 7. Is only half factored here. We have x squared plus 3x plus 2 equal to 0. And we know one of the terms is 2. When we FOIL, we know x times this value here has to give us an x squared. This must be an x. And the 2 here multiplied by this value must give us a 2. Must give us this 2 here. So it can be a plus 1. Of course, we can use splitting the middle method, but we don't need to. In this case, they already have half the solution. Now we use the zero product property. We set x plus 2 equal to 0. We solve for x. X equals negative 2. Or x plus 1 is equal to 0. We subtract 1 from both sides, and x equals negative 1. Number 8, x squared minus 6x minus 27. When we multiply the outside terms, 1 times negative 27 is negative 27. So we need two numbers to multiply the negative 27, but they must sum to negative 6, to the middle term, negative 6. What two numbers could that be? How about 9 and 3? They multiply to 27, but we need a negative 6. What if we make the 9 negative and the 3 positive? So we could do negative 9 and a positive 3. So do x minus 9 and x plus 3. If you were to FOIL this out, you would get the quadratic function x squared minus 6x minus 27 equal to 0. Now we use the zero product property. We'll set x minus 9 is equal to 0, or x plus 3 is equal to 0. Now we just solve for x in the first part. We add 9 to both sides. We get x equal to 9. Or here we're going to subtract 3 on the other side. We get x equals negative 3. Number 9. X squared plus 8x plus 15 is equal to 0. What two numbers multiply to 15, but they sum to 8? Factors of 15 could be 1 and 15. Could also be 3 and 5. 3 and 5 do work. So we do x plus 3, x plus 5. We'll just set each term equal to 0. So x plus 3 is equal to 0, or x plus 5 is equal to 0. When we solve, we'll get x is equal to negative 3, or x is equal to negative 5. Number 10. Now, what two numbers multiply to 5, but they sum to negative 6? What if we did negative 5 and negative 1? They multiply to 5, but they sum to negative 6. So we do x minus 5 times x minus 1 equal to 0. And we set each of these equal to 0. And of course, we're going to get x is equal to 5, or x is equal to 1. Number 11. X squared minus 4x minus 12 is equal to 0. We need factors of negative 12, but they sum to negative 4. 4 and 3, 12 and 1, 6 and 2. What if we do negative 6 and a positive 2? That will work. So we'll have x minus 6 and x plus 2 equal to 0. We solve when we get x is equal to 6, or x is equal to negative 2. Number 12. Now, before we've been doing all the problems we've been doing were 1x squared. Now we have a 2 in front. So we must multiply these. We need the factors of negative 6, but they must sum to negative 5. Two numbers that multiply to 6. How about 3 and 2? But if we use 3 and 2, they have to both be negative. Negative 3, negative 2 to get the sum to negative 5. But that gives us a plus 6, so that does not work. How about negative 6 and 1? Would that work? Negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. So that does work. So we're going to do 2x squared. We're going to split the middle term here. Minus 6x plus 1x minus 3 equal to 0. We split the minus 5x into minus 6 and 1. Now we're going to do the factor by grouping. Out of the first two terms, we can factor out a 2x. 2x times what will give us 2x squared minus 6x? Well, we can put an x here and a minus 3 here. If we distribute, we'll go back to the original. Now, the last two terms, all we can factor out is a 1 plus 1. Now note, these two are the same. So we're almost done. We can now finish factoring as x minus 3 and 2x plus 1 equal to 0. And we solve. X will equal 3, or we have to solve this equation here, but we'll subtract 1 and divide by 2. Or x equals negative 1 divided by 2. And there's our two solutions. Number 13, 6x squared equals 5x plus 4. There's a little problem here. It's not set equal to 0. When we factor, we need to have this set equal to 0 for factoring these trinomials. So we're going to move the 5x and the 4 to the other side. So we have 6x squared minus 5x minus 4 equal to 0. Now we have to find the factors of negative 24, and they must sum to negative 5. 12 and 2, 24 and 1, 8 and 3, and 6 and 4. If we do 8 and 3, and we do a negative 8 and a positive 3, that will work. Those two terms do work. So let's split the middle. We have the 6x squared still. We'll split the minus 5x into minus 8x plus 3x. You see, we split the minus 5x. It goes to minus 8x plus 3x and minus 4. We now factor the first two terms and the last two terms. The first two, we can factor out what value? How about a 2x? And we'll get a 3x minus 4. The last two terms, we can only factor out a 1. So we can now factor this. This becomes 3x minus 4 and 2x plus 1 equal to 0. And we will now solve. Hopefully we're getting more comfortable in solving for x. Here we will add 4 and divide by 3. So x equals 4 divided by 3. Or here we will subtract the 1 and divide by 2. Minus 1 over 2. Whoops, that was a bad. See if I can box that a little bit better. There we go. Now here's our only word problem, number 14. A relief package is released. I'm sorry, let me see if I can clear that out. There we go. A relief package is released from a helicopter at 1,600 feet. The height of the package can be modeled by this minus 16t squared plus 1,600, where h is the height and t is the time. If we were to have it do a graph here, always remember that time is almost always on the x-axis, also known as the independent axis. And the height here is a function of the time. If we were to graph this equation, we could find the y-intercept first by plugging in 0 for t, and we get h is equal to 1,600. So this is the starting height of 1,600. It's a negative t squared, a negative parabola, so it's going down. The truth is it's also going down on this side, but we don't need to draw that because that's when time is negative, which is not possible. We cannot go backwards in time. As far as we know, nothing with mass can go backwards in time. But there are particles can go backwards in time. You'll study that later because it seems like photons and electrons have mass, and they may be able to go backwards in time too. And we're not sure yet. Let's see. So first it says to write the equation, and then we're going to solve it. What they mean here is the equation, of course, is minus 16t squared plus 1,600, and they want us to actually factor that. What can you factor? And of course, when we're trying to find that the height would be equal to 0 when it hits the ground. So we have our equation. This is only a 2 terms, and the best way to solve this is just to go and factor out a GCF. What would the GCF be between minus 16t squared plus 1,600? We can factor out a minus 16. And we will get t squared minus 100 over here equal to 0. So we can now use the zero product property. We have 0 is equal to minus 16, which does not make sense. We'll throw that out. And we have 0 is equal to t squared minus 100. And do you remember these difference of squares? Difference of squares. This is what we just encountered. A difference of squares factoring problem. This factors to t minus 10 and t plus 10. Now we solve using the zero product property. We get t is equal to 10 seconds and t over here is equal to negative 10 seconds. Again, we can't have a negative time. That negative time is actually the time over here. But it's a nice parabola and it's very symmetrical about the y-axis. T equals 10 seconds is the answer. Well, this concludes this lesson.